We're now going to be starting in the guided practice packet, which is the blue one. We're going to skip some of these, and we're just going to do what I think you guys need to make sure you're good for the homework quiz. So let's start with number 9. So here, we might need to do the quadratic formula. We might be able to factor it. What should we do before we do anything? Put it in standard form. Whether we are solving by factoring or solving using the quadratic formula, it's got to be equal to 0 before we can factor it. Next, I'm going to go ahead and go to my y equals and just type this equation in to just see what the x-intercepts look like or don't look like. Ooh, and I see that I have 2 of them. Now, are those x-intercepts exact? I don't know. If I hit trace and try -2, ooh, it doesn't look like -2 is a root, which means 1 probably isn't a root either. So, folks, what should I do if it doesn't look like my roots are nice? Probably the quadratic formula. They could be fractions, so I mean, we could try to factor this just to be safe. 3 and 3, there aren't many combos to try. That gives me 6x. That gives me 6x. That's a no-go. We can try 9 and 1. That gives me 2x. Gives me 18x. That's a no-go too. We can try 4 and 1. 4x and 9x. That's still a no-go. And then we can flip the order. 1 and 4. 1x and 36x. Oh yeah, that's not it. Or we could try 2x and 2x with the 9. Let's see, that gives me, or no, I would try the 1 and the 4 with 3 and 3, that's right. So then that gives me 3x and 12x. And then if I flip those around, that would give me the same thing. So yeah, we have exhausted our factoring choices. You can go ahead and cross off number 12, and we're going to make use of the space down here. So making sure we're using the standard form equation. Quadratic formula is -b, -4, plus or minus the square root of b squared, 4 squared, minus 4, a value, 4, c value of -9, all over 2 times 4. We start with the discriminant. So now we are doing the full version of those problems we were doing in the green packet, where we got to get the stuff under the square root first. So when you type this in on your calculator, make sure you're not including the square root. So 4 squared minus 4 times -9. Don't need the parentheses because that 4 is positive. You can put them in if you want, though. And we get 160. So 4 plus or minus 160 over 8. What's looking like it might be the biggest perfect square I can take out of 160? I see that it has 16 in it. If 16 and 10 are factors, can I take any more perfect squares out of 10? Nope. So 16 is it. So 16 and 10 all over 8. We're running out of room. Let's sidebar over here. So -4 plus or minus 4 rad 10 all over 8. Division, distribution. And x equals -1/2 plus or minus rad 10 over 2. Now, because these are irrational, can I check myself on my calculator? Sure can. We saw those x-intercepts. They exist. So, folks, to go through these steps, you hit your trace button and then type -1/2 plus square root of 10, and make sure you close off the parentheses to say I am only taking the square root of 10, and then divide it by 2. Boom! Right on the money. That is my x-intercept. And if I checked the negative version of that, so -1/2 minus square root of 10 divided by 2, we see that that gives me the other x-intercept. So yes, these problems are hard, but the rational ones you can check on your calculator, the irrational ones you can check. The only ones that you can't check are the imaginary ones. Any questions on that one? On any of those first few steps? Okay, turn the page. And we're going to do the bottom 3 problems. So 16, 17, and 18. Now on 16, what should we do first with this problem? Put it in standard form. Now take note that my A value is negative. It's not a big deal for the quadratic formula, but it is a big deal for factoring. And it actually does make the quadratic formula a little bit easier as well. So instead of subtracting the 10 to move it over to the left side, let's go ahead and add 4x squared and add 10x to move those to the other side. So now my standard form equation, 4x squared plus 10x plus 10. So I just wrote a bunch of even numbers. Can we factor that? Yeah. So take a 2 out, so 2x squared plus 5x plus 5. Sweet. Now if I want, I can plug in that original equation, 4x squared plus 10x plus 10. Let's just see what the graph looks like. Ooh. Why, ooh. Is this going to have x-intercepts? Not real ones, so should I even bother trying to factor? No. This graph is floating up here. That means imaginary or complex. We're going to have I stuff, so we're going to use the quadratic formula. But here's why I wanted to show you this problem. Yes, we could use these original numbers, but taking out a GCF, I can actually use the quadratic formula with those smaller numbers. So even with the quadratic formula, if you take a GCF out, you can now use this new quadratic with smaller numbers, less simplifying to do, in the quadratic formula. Quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2 times 2. Take it from here, ladies and gentlemen. Ooh, what do we get for the discriminant? Negative 15. Is that good? I mean, yeah, because we already figured out that we should be getting imaginary solutions. So if I didn't get a negative number there, that would be kind of cause for concern because it's like, well, where are we going to get that I from? So always a good check to look at your graph to see if it matches what you are solving. So then we take the I out. Are there any perfect squares we can take out of 15? That's a no. So division distribution, we get negative 5/4 plus or minus I rad 15 over 4. That's as simplified as that turkey will get. It's not pretty. We can't check it, which is kind of unnerving, but we use smaller numbers, less simplifying, so that's as good as that one can get. All right, folks, on your own with the next one. Use your calculator. Look at the graph. Try to factor it. So folks, hopefully before you tried graphing this one, you did put it in standard form. So we add 7, and we get 4x squared minus 1 equals 0. So we don't have a b value. Anything jumping out at you about 4x squared and 1? Maybe it would help if we explicitly added this to our purple sheet. In your perfect squares column, there is one that we don't have on here because we don't really use it when we're simplifying square roots. 1 is a perfect square whose perfect square factor is 1. Not useful for simplifying square roots, but it is useful when trying to factor difference of squares. Perfect square factors of 4, 2, and 2. Perfect square factors of x squared, x, and x. Perfect square factors of 1, 1, and 1. 1 gets a plus, 1 gets a minus, equals 0. Set each of those factors equal to 0. And we get negative 1/2 and positive 1/2, which thankfully we can verify on our calculator. I type in that equation, I look at the graph, I hit trace and type negative 1/2, boom, there's one x-intercept. I type positive 1/2, boom, there's the other x-intercept. How would you describe these? 2 rational roots. How many of you factored that one? How many of you used the quadratic formula? Did we get the same answer? Did we do the plus minus case directly? Again, on the test, you'll have one section that's just factoring and one section that's solving. So as long as you can get to those x-intercepts, you can do factoring or the quadratic formula. Folks, let's go ahead and take a look at the next one. It's in standard form. Can I factor that? Yeah, when there's no x method necessary, product of negative 24, sum of 2, x minus 6, x plus 4, and x equals 6, x equals negative 4. And you can check it on your graph and see that that is true. All right, folks, that's it from me for factoring, I think, unless after the homework quiz, I think that we need more practice. I think you guys are ready to rock with this. So let's clear everything off your desk except for that purple sheet. And let's see how we do.